Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Let me introduce myself. My name is Arianti Ramadhani from Universitas 11 Maret. Now I will presentate my paper, which the title is Natural Weathering on Recycled Polypropylene Bamboo Fiber Composites. The main objective of this study was to analyze the effect of natural weathering on the tensile strength and microstructure of recycled polypropylene composites with bamboo fiber reinforcement using scanning electron microscopy or SEM. Polypropylene has resistance to chemical reaction. Because of these superior properties, polypropylene is the type of plastic that is most often used in everyday life. Recycling plastic waste is the way to reduce the amount of plastic waste and process it into new materials such as composites and edge. Bamboo fiber is widely cultivated in the Asia-Pacific region. Bamboo has an abundant global production of 30,000 kilotons annually. The strength and stiffness of bamboo fiber is comparable to that of glass fiber or wood fiber, but bamboo fiber has a much lower density and is cheaper than glass fiber and wood fiber. Research about natural weathering of recycled polypropylene composites reinforced with bamboo fiber should be carried on again to enrich the reference. With an abundant amount, bamboo fiber and polypropylene plastic waste are still underutilized. The mechanical strength and morphological change of recycled polypropylene composites and bamboo fibers exposed to UV light, rain, and wind need to be studied in order to be able to apply them widely, both indoors or outdoors. Composites of recycled polypropylene bamboo were made with a composition ratio of 90:10. First, crush polypropylene and bamboo into mesh 5 and then treat crushing bamboo by 5% natrium hydroxide before mix them into one. And after mix them, melt the composites using extrusion molding and injection molding machine. Natural weathering research is carried out by placing composite specimens on a shelf with an angle of 45° facing east outdoors, so that the composite is exposed directly to sunlight, rain, and also the surrounding air. The test was carried out with variations in duration of 0 months or without exposure 1 month and 2 months. The test procedures refers to the ASTM D1435 standard. In the tensile strength test, a built-in application called WinTest TM analysis is used with self-diagnose technology, with the overall result in the form of digital data including Young's modulus, stress, and strain. The 3 variations of different samples, which are 0, 1, and 2 months sample that have gone through a tensile test, will go through a coating process with gold palladium and then observe using a scanning electron microscopy or SEM. The things that will be observed are the condition of the recycled polypropylene matrix, the bond between the reinforcing fiber matrix, and also the shape of the bamboo fiber after exposure. And this is the result, and the results from average of air temperature. The highest average humidity at the time of specimen exposure was 85.6%. Occurred in June, evaporation that occurred was only 3.7% lower than other months. This is because the radiation in June is low and the rainfall in June is quite frequent. During the winter exposure to the composite, there is a fluctuating difference in rainfall. Head of BMKG Semarang Climatology Station, Sukasno, said the start of the 2021 dry season in the Central Java region fell in April until June 2021. In research, it was found that there was a white layer or chalking on the surface of the plastic composite after being exposed to outdoor weathering. The content of the white layer or chalking depends on the composite manufacturing process. Weather variables and UV light intensity. In the sample A or 0 mon variation or without exposure, the surface is still black. And then in B or 1 mon variation, sample begins to form white spots, and the sample surface in C or 2 mon variation, the white spots are formed more and more. It can be seen that the longer the exposure to the weather, the more the color of white or chalking appears on the sample surface. These changes indicate degradation due to UV radiations. And then this is yield of your modulus tensile, strength and elongation. In a sample that without exposure, it has the lowest tensile strength value of 18.1 MPa. Then the 1 mon variation composite began to increase in the value of its tensile strength to 19.5 MPa. This was due to the high degree of polymer in the polymer long chain owned by polypropylene, which could increase the mechanical strength of the composite. The elongation or ductility that occurs in composite specimens after being exposed to weather continues to increase. Starting from a 0 mon or without exposure sample with an elongation of 5%, then after a month of exposure, the percentage increased to 6.4%, and then increase again to 6.6% after 2 months of exposure. Elongation itself is a condition when a composite specimen breaks after undergoing a change in length due to strain. The small value of tensile strength in the without exposure sample is caused by the polymer chain bonds that are not yet in perfect condition. The tensile strength of the composite with a variation of 2 months decreased by 19.3 MPa. The decrease was obtained from the effect of UV light causing polymer degradation, which result in damage to the microstructure of the composite specimen. However, the decrease that occurs is only 0.2 MPa compared to the tensile strength in the 1 mon variation sample. And then this is the same result for no exposure sample. In the no exposure sample, the recycled polypropylene bamboo interface bond was still intact. The bamboo had not been damaged by weather exposure such as rainwater and sunlight. Meanwhile, the shape of the bamboo of the surface of the recycled polypropylene that looks slightly damaged are caused by the sample breaking during the tensile test. Then, there is a part of the recycled polypropylene matrix that forms many voids, namely the holes formed due to the trapping of oxygen during the process of making composites specimens. The formation of voids in the polymer matrix can cause a decrease in mechanical strength. And then this is same result for 1 mon sample variation. Same variation of 1 mon, it can be seen that the interfacial bond between the reinforcement and the matrix is still intact. The gap between the matrix and the reinforcing fiber hasn't been seen, making the 1 mon sample variation the sample with the highest tensile strength value. It's just that the bamboo fiber has started to show change due to absorbing water and then being exposed to UV rays or sun heat and being slightly damaged. And this is the result for 2 mon sample. variation, the bamboo fibers in 2-month variation began to break down due to the frequent rainfall in June, which caused the bamboo to absorb a lot of water, and finally the fibers were clearly damaged. Then the gap between the bamboo and recycled polypropylene matrix has been formed, and many cracks and pores are formed in the recycled polypropylene matrix. And then the conclusion from the research that has been done, the following conclusion conclusion can be drawn. First, after natural weathering, it was seen that the composite specimen underwent slight physical change, starting from the 0-month variation specimen, which is physically still black. Then after a month variation, it starts to appear white on its surface, and then the white color increases in the 2 months variations. Second, the tensile strength in sample 0-month or without exposure 1 month and 2 months respectively were 18.1 MPa with an elongation of 5%, and then 19.5 MPa with an elongation of 6.4%, and then 19.3 MPa with an elongation of 6.6%. The 0-month variation becomes the sample variation with the highest Young modulus value of all sample variations, which is 222 MPa. Then sample with amount exposure is 206 MPa, and then the last for 2 months variation is 141 MPa. The result of the same test show that at the no exposure variation, the bond between the matrix fiber was still good, but there were many voids formed which affected the tensile strength of the composite to be weak. Then in the 1-month variation sample, which is the variation with the highest tensile strength, it turns out that the bond between the fiber matrix is still good, and in the 2 months variations, the gap between the matrix and bamboo begins to form. The bamboo fiber has absorbed a lot of water so that the shape isn't very intact. This causes a decrease in the value of the tensile strength of the composite. Thank you very much for the attention. Wassalamualaikum warahmatullahi wabarakatuh.